Hi, welcome to Cloud Cover. My name is Ryan Dunn.
And I'm Steve Marks.
Hey, great show this week. We're going to be going through the news as usual. In addition, we're going to have the feature this week be on using the Hostable web core along with Windows Azure drives. Why drives this week? Well, we had one of our many Twitter followers actually suggest a feature using Windows Azure drives.
And this wasn't a fake one
no,
like before. This was an actual person on Twitter who really wanted to see drives.
Yeah, this was not Samantha J. Billinger from Montana.
It might have been. We don't know whose Twitter account it is.
That's true. Actually, it could be her.
Could be her, but probably not.
Yeah, I think the name was like Ed or something.
That's short for Samantha.
The tip of this week will be actually a tip on how to optimize the efficient transfer of your drives up to cloud storage and save on the bandwidth charges as well as the sitting charges. So,
Indeed.
Let's get started.
Yeah, let's do some news. This news comes from some guy's blog. His name is, I think, Ryan Dunn.
I think it's Mr. Mumblings.
He wrote some book, I guess, like a million years ago. But anyway, he announced the version 2 of the Windows Azure Management, what's the other M? Microsoft Management Console.
That is correct.
So it snaps into MMC, as most of us know it, and it does all sorts of cool stuff, like let you manage your hosted services, take a look at diagnostics, manage certificates, browse your storage, I don't know, a whole bunch of stuff.
It even cooks you dinner, I've heard.
And it is built on the PowerShell commandlets.
That is correct.
So way under the covers, it's those same PowerShell commandlets, which we have shown here before on the show, but this has some pretty fancy UI on top of it. There's also a little screencast at the bottom. Don't miss it. It's buried down here. There's no little screenshot or anything, but 15-minute screencast. Click the button, and you can watch how to use it. This is actually a really cool tool for doing a number of things with Windows Azure.
Thanks, Steve.
So, moving right along, what do we have next, Ryan?
Well, Mr. Wegner, a.k.a. Wade, who is about to actually be our new Windows Azure platform app fabric.
What's the deal? He isn't yet
evangelist.
Sorry, I should have let you finish that.
Yeah.
But he's not yet. That's what his blog says. It says about to be, soon to be.
I think
he's like still in transition.
Something like that. He'll be in July.
Because all he's talking about now is like Service Bus. So I figured he's already doing it.
If he's not already, he's kind of jumping the gun.
That's what I think.
Yeah.
It's just volunteer work right now.
Exactly. You think his job right now is happy that he's getting paid to do someone else's work? I don't know.
Yeah, that's kind of strange.
Well, he posted actually on his blog how to host WCF services in IIS. Now, this might seem like a duh kind of thing, but actually it's more difficult than you would first consider. And the reason is it's really a chicken and egg problem. You have this activation service that you really need to, in order to have a service up and listening, you have to activate it. And IIS usually activates on the first request. Well, in order to use the App Fabric Service Bus, you have to already be activated and listening on the service bus. So you kind of get into this weird scenario where IIS tends to be not a perfect host right now.
I like how Wade put it here. Until the first message is received by IIS, the service will never establish a connection to the service bus. But with no connection to the service bus, it will never receive a message. So,
yeah. Just
as you said. So what's the fix? How do you do it?
Well, he lists 2 fixes here, actually. One of them is using the warm-up services on here, so the IIS application warm-up. And the other is more specific to ASP.NET 4.0 Auto Start. And anyhow, they both kind of involve warming up IIS with a first request so that you get the host up and listening on the service bus, and then IIS becomes a pretty good service to host this, obviously.
Very cool.
Yep. So go check it out. Wade has a lot more on that blog post.
Wade is the man, by the way. Can I just say officially, I'm very excited that Wade is going to be evangelizing the Windows Azure platform because he's a cool guy and really knows what he's talking about.
Yep, very excited about it as well, you can tell.
Yep. So, SQL Azure connections.
Right. This is just one of those great FYI blog posts from David Robinson, the SQL Azure team. And basically, it goes into how the connection works in SQL Azure. It's a little bit different than on-premises because of the way timeouts and things can occur. So we have in here a way to actually, some code to help you manage the connections and get your retry policies and whatnot in here. And it's just a best practice that you want to take a look at, maybe swipe some of this code. So when you use SQL Azure, you know exactly how that connection might behave. It could get dropped, you could be throttled, and you want to have this retry mechanism in place in order to keep your connection up and running.
Sounds familiar because it sounds exactly like what we tell people about Windows Azure storage, is that, hey, you may get throttled, there may be network glitches, everything should be wrapped in retries, and so cool to see that same pattern applying to SQL Azure.
It's just much more apparent when you're obviously out on the internet and you have this WAN link versus when you're on premises. Most people never give it a second thought of why would a database connection, break? You usually don't have those.
It's
glitches.
the machine right next to the one that I'm on.
Exactly.
Right?
Or the same machine.
Yeah, often that's true.
Now, this post comes along from Vittorio Bertocci. He is the identity evangelist here at Microsoft. And this announcement is actually an update to the Identity Training Kit, which includes how to federate using Windows Azure. So when we talk about federation here, we're talking about WS Trust and WS Fed. And this is different than the access control service. I don't know if people know that sometimes, but this is actually the federation that you see, that passive kind of token dance, single sign-on, a lot of people associate to. Well, anyhow, this was updated to now the Visual Studio 2010 release of Visual Studio, I guess. So the project files have been updated, and it includes in here that lab on how to do that yourself. So it's a great resource. You just pull it out, and you can really actually get up and running with Federation in your app running in Windows Azure pretty quickly.
Cool. And the Windows Azure storage team has been continuing to be on a roll in terms of blogging.
They're in Fuego.
They are en fuego. I think it's official. And this post is actually about the scalability targets for different Windows Azure storage abstractions. So blobs, tables, queues, drives, what can you expect? How many requests per second can you get? What's the throughput look like? What's the, what are the scale targets for these things? So it goes through and basically gives you the basics of these things, tells you things like what the maximum size is, tells you even some things that a lot of people don't know about Windows Azure tables, like that you can have a maximum of 255 properties.
I said that last week.
Why is it not 256? I don't know. It's a mystery. Combined size of all the properties can't exceed 1 megabyte. I think you said that last week too.
Wow.
All right, fine. Ryan told you all this stuff, so you already know it. But maybe you don't know it about queues. Maybe you don't know about...
like, for instance, all queues have to start with the letter K.
Yeah,
no one knows that.
No, very few people think that that's true.
Yep.
And I don't think anyone in this room thinks that that's true. Partitions, that's actually kind of interesting because it's very explicit when we talk about tables what the partitioning structure is, but blobs have partitions too, and it's actually the entire name of the container plus blob, and so that's kind of interesting. The queues also have a partitioning namespace. So you should know those things. Down here it actually has these performance targets, things like 500 transactions per second, 60 megabytes per second in throughput on a single blob. Very cool. So check this out. It's got a lot of details in there. Brad is, as we've said before, Mr. Windows Azure Storage. So if he says it, it is true.
He's the grand poobah of Windows Azure Storage, first of all. Secondly, look at how long this blog post is. I mean, this is almost a book.
It is pretty long.
And this is the first in a part of in a series, isn't it?
That is true. Isn't it the second in a series?
It might be the second in
Wasn't
the
there
series.
one that just introduced all the concepts?
And it has a table of contents. The rest
I don't know.
of the
It was so long I didn't read it. So, I mean, it's... just like this one. All right, with that, it's probably time we get to this week's feature, which relates to storage. We're going to talk about drives, and we're going to do it in the context of this hosted web core stuff that's actually kind of a pet project of mine. And I'm basically going to go through how to take this hosted web core worker, which is the thing that I've been working on, that basically lets you mimic a web role but gives you a little flexibility about where your application is, and you can put it on a writable location on the disk. You can sync it with blob storage. There's a blog post I did about that a little while ago. Here we're going to say, well, what if I wanted to put all my website content into a drive, but then get it hosted on Windows Azure? So I've got a little project here that does it. And so let me show you the part that's not unique to drives here. And there's kind of all this stuff, setting up a bunch of parameters, writing out application host config files and web config files, and then launching hosted web core. So
yeah, just to kind of back up a little bit, we should probably explain this is done for you automatically in the IIS web role. We are running hosted web core in the IIS web role. It happens to be that the worker role images also have hosted web core on them, and you've tapped into what's there on disk and basically are turning it on, but because you're kind of more manually controlling it, now you can tweak parameters, you can do these things. So part of that startup is you got to set those parameters to get going, what would otherwise be just taken care of for you automatically running the web role.
Exactly. This is a bunch of sort of manual work that does
kind of glue code.
Mimics what the web role does. Right. And so it has this parameterized application host config, and in the web role that's just magic. There's just an application host config there that looks right. Right. Same thing with web config. There's actually very little in web config that I need to do there, but that's happening. And this is part of some code that is you can find through my blog, or it's actually up on MSDN Code Gallery at code.msdn.com/hwcworker. I'm going to guess. We're going to put a link on the thing anyway. So you can get that code, okay? And that's the basic code that just says, how do we set up hosted web core and get it running? And the reason to do it is, as you said, to gain some flexibility. By doing it manually, it means I can change things. So I can mess with application host config, change some of the settings that are locked down in a web role, but you can do running hosted web core. One other piece of background, actually, that probably should have said up front, hosted web core is basically a way to run IIS in sort of a single process kind of mode. It's not the full IIS thing, but it's sort of the core, perhaps, the C in HWC core of IIS that lets you run things. So it's basically a way to kind of programmatically, with your own process management, launch IIS. And that's what we do in the web role, and that's what I'm doing in this kind of hosted web core worker role. Okay, so now that we've got that, the question is, back to our scenario, what if I wanted to stick all of my content in a Windows Azure drive and then use it here? So let's talk a little bit about Windows Azure drives. Windows Azure drives are nothing more than page blobs that I treat differently, right? So underneath a Windows Azure drive is a blob that I usually put a VHD ending on because it's a virtual hard drive. So I can construct that on Windows 7 using the tools that are built in, or really anything that can produce a VHD. Or there's an API when I'm running in the cloud where I can just create one there. Put a bunch of stuff in it. Now I've got a file that's a VHD file. I put that in blob storage as a page blob, and go read that blog post we actually just pointed to. It talks about page blobs and how those are different from block blobs. But basically, they're oriented for random access reads and writes, which is perfect for mounting a virtual hard drive. So then what turns it into a Windows Azure drive is that in my code, in my worker role here, I'm going to connect up to that VHD and mount it locally. And then every write that I do is going to go through to the VHD in that page blob. Every read that I do is going to come from that page blob. And there's a local cache that kind of makes that a little bit faster. So that's it. So it's actually really the magic of a drive all happens kind of on the VM where you're using it, because we mount it with this special driver that treats it that way. So it's not really different from taking a VHD, copying it to your machine, mounting it, and just going and looking around. It works pretty much the same way, but over the network and backed by durable storage.
Right.
So that's all a drive is. So let's get the mystery out of there. That's all it is. The nice thing is once you've got it all set up, it looks like just another drive letter on your machine, and it's got a bunch of content. So I can point my hosted web core at that resource.
There's, I mean, in addition to what you're talking about in terms of the page blob underlying it, there's also some intrinsic built into Windows Azure storage around, like, for instance, the leasing mechanism that's used.
Yep.
You can lease the blob yourself. If you wanted to, you could lease any blob really yourself. But what that driver does that's running in the VM is it's doing that, all the stuff, the infrastructure stuff for you. So it's maintaining the lease, and when you go and you flush your writes to the NTFS emulation, it goes in and it uses the correct page write semantics under
Yep.
the covers. To you as a developer, you know nothing about it. You're just using like file.open and file.write and those kind of things.
Right.
That's all done underneath. But there's some more stuff in there that it's doing that you could actually get a hold of yourself if you wanted to under the covers.
Right. All those are just features of blob storage, right?
Yep.
The ability to lease. And actually, one thing that's important to point out about drives and how you can use them is that you can mount a drive in read-write mode.
Yep.
And if you do that, then, as you said, a lease is acquired on that blob, and that lease is continually renewed while you're using the blob, right? So you're going to mount the VHD, you're going to do read-write access against it. No one else can mount it because there's that lease
on it,
there's an
right.
active lease on it. The reason for this is because you don't want two different VMs mounting the same virtual hard drive and both doing writes at the same time, because it's an NTFS volume. It's not designed for sort of concurrent writes. Right? So
exactly.
this isn't like a UNC share or something where there's a different protocol there. This is just NTFS, so bytes are getting written and read, and if those happen sort of in the wrong combination, you'd get totally invalid data. Right? So you want to have an exclusive lock, if you will. In the cloud, everything we do is leases in case something dies and has to time out, right? So you get a lease and you maintain that lease through the whole life cycle. There's, if you want more than one instance in the cloud to be able to mount the drive, you can do it as long as it's read-only, and that's actually what we're going to do here. We're going to mount a read-only snapshot of the blob. Now, again, snapshot is just a generic blob storage feature,
Right.
so it has nothing to do, the fact that this is a VHD has nothing to do with the way that I do snapshotting. But when I mount it as a Windows Azure drive, if I mount a snapshot, then I have a read-only drive, and everybody can mount that same snapshot. There's no issue with concurrency because there are no writes.
Correct.
So it's fine if everybody does reads at the same time. So that's what we're going to do here. Here's the first thing that you have to do is you have to initialize the cache. So if you remember, the driver that works in this VM and mounts this drive uses a local cache to make things faster, right? Just so that the reads and writes are can be cached. So you have to initialize that cache with some local resource. So I've got a local resource called drive cache, which I just in Visual Studio added as a local storage resource, and I'm going to grab that path, and then hey, big gotcha here. Make sure that you get rid of the trailing backslash if there is one on this path. This is actually on the Windows Azure storage blog. There is mention of this if you read the post about Windows Azure drives. This is just a bug that we just don't properly handle this trailing backslash. So hopefully that'll go away at some point, but for now, just make sure to chop it off. And then you give the size. And here I've actually put in 1,000 because I happen to know that's what it is. There's actually a handier way. If you get the local resource, there's like a maximum size attribute that I was just too lazy to use, but that's probably a better thing
Not
to do.
Not 1024 either, but 1,000.
No, 1,000. I
hate that base 2 thing.
I like my gigabyte should be 1,000 times a megabyte. That's what I want. And well, multiplying by 2 is hard. So then we've got to actually create the cloud drive. Now this is not creating a file, or this is in the same vein as when you have an account and you do like create cloud blob client. That's sort of what this is. This is basically going to give me back a reference. And so it's not actually going out and doing something against storage. And I'm going to use a URL that I've put in my configuration settings, so drive snapshot URL. So I'm going to name a specific snapshot because I want read-only access to this because I'm going to put it on several instances for redundancy, etc. I want them all to be able to read it. So I'm going to use a snapshot. I've put that snapshot in a config setting.
That's just the blob.core.windows.net/container name
absolutely.
/ some blob VHD snapshot
Question mark
thing.
snapshot equals
right.
some datetime thing. Yep.
No magic there.
That's all it is. No magic there. Here, I've got a little like create it if it doesn't exist thing. I'm not actually using this in the cloud, but when I was running this locally and doing some testing, locally things work a little differently with drives. I don't really want to get into all the differences here, but it's sort of faked with a local disk, just a folder on your drive. So instead of actually mounting a VHD, you don't actually have the driver here that's in the cloud. And so it's sort of faked up with this thing. And so just to get that started, I have this create code in here. But in the cloud, I expect that I already have a VHD with a snapshot, so I'm just catching the exception that says it already exists and moving on. Here's where I actually mount it. Again, I've hard-coded, a non-power of 2, but powers of 10 are even better, 1,000. And I've said no mount options. There are a couple options, and really the important one that comes up in other cases is force. And if you forcibly mount a drive, what that means is it'll break the lease that somebody else has. So if somebody else has this thing mounted, they are renewing that lease continually. If you say force, that will break the lease, which means when their time is up, they can't renew. So it'll stop them from being able to renew the lease. You'll get to take over that lease, take over that drive. In the case of a snapshot where I don't need the lease, I don't need exclusive access, I certainly don't need to use that. In normal cases, you won't use it either because you'll want to wait till whoever has it willingly gives up the lease instead of forcing them to break it. That's about it. Then there's a little line of code that I changed here that basically sets up in my application host config where it's going to point to, and it points to that path to the drive.
That's where the hosted files are for the website. That's
right. This is pointing to where am I pointing hosted web core at? What's the website content? Let's take a look at quickly how I created that. So here I've got a VHD that I created, and here's how I did it. Let's look at this create.txt. This is a script that I'm going to pass to diskpart, the disk partition tool. So you use it by doing something like this. I'm not going to do it now because the thing already exists, but it does this. I'll put this stuff up on my blog, so there's no need to frantically write it down. But this just creates a fixed VHD. It has to be a fixed VHD for it to work with Windows Azure drives. Gives it a maximum size of 30 megabytes, just a little bit small. Creates that VHD, assigns it a drive letter. There's another one here that I've got called mount, and if I can run that one actually. Let's just do diskpart-s mount. After I do that, so that just finds that VHD and attaches it. So then if I go to V, which is the drive letter that I used up here, dir, that's all the content that I'm going to have up on my website. And this I just copied in locally. This is exactly what I did. And lastly, there's an unmount, which just unmounts the drive, does the same sort of thing. I guess I should pull up the text for that too, in case somebody doesn't want to go to my blog and see it. You can do this through the UI too. If you're a wuss like Ryan, when I was talking to Ryan about this, he said, "Oh, it's easy. You just go to the computer manager properties." I don't know. He told me something that I couldn't follow, and then I immediately looked for a command line tool for it. But you can do this through the UI. There's in Windows 7 and in Windows Server 2008. You can just go and right-click and say new VHD and whatever, and you could, of course, you can do it with PowerShell. So I did it probably the hardest way possible, but in case anybody else wants to do it that way, you can. And then how did I get that up in the cloud? I used a tool that I think we've shown on here before. This is Clumsy Leaf's Cloud Explorer tool.
Yep.
It has an upload page blob function, and I can just choose that blob, and it uploads it. Then I needed a snapshot. Went to the properties, went to snapshots, and I pressed create. And I created a snapshot. These are the snapshots that I made before. That's about it. Then I needed to just set the config setting, go deploy this thing to the web, and you get some amazing thing like this. So this is actually...
This is the most anticlimactic demo I've ever seen. So we have hosted web core running on a snapshotted read-only blob, and you could have like multiple instances of this running.
And I could have anything I wanted here.
And you chose Hello World.
This is absolutely, the world is my oyster. and I chose Hello World. I'm not really that creative, it turns out. So anyway, but this is actually, that's the stuff that I put in that VHD. I uploaded, I created a snapshot, I set the config setting, deployed this thing. I see Hello World in the browser, but this could be anything. And this means if you want to just manage your... Snapshots are also a handy way to manage sort of versioning of things. And so if you want to have your website content sort of in a VHD that you know that that each snapshot you're sort of keeping those backup copies of older versions, you can easily do this, and all you have to do is set a config setting.
Or you just develop the whole site locally on a mounted VHD and upload it up into Windows Azure, and you're kind of done.
And voila.
Voila.
So, so that's about it. I mean, so I'll do a blog post that follows up on this and talks a little bit more of the technical details. Maybe I'll show a little bit of what the development storage version of this looks like, because it is a little different, and it actually took me a while to get it going and get it working right. So that's probably worth giving a few hints on.
Great.
So people can go check out my blog if they want to see some further examples of this.
Now is the time for the tip of the week.
It's my least favorite time.
But I have this one.
Okay.
And all I can say is I had a secret agreement with the editor before the show. So he knows what it is. And
That's cheating.
And all I can say is, Steve, you're gonna be finding out after the show. So it's time to power up and eat that magic mushroom there, Steve. Here's your tip of the week.
I've been set up. I don't know what happened, but I had no knowledge of it. Let's just move on and talk about the tip of the week. The tip of the week is about page blobs, and really the most common time this comes up is when you're using Windows Azure drives and you're using a VHD, but it actually applies to page blobs in general. So the thing about page blobs is that they have, a page blob is basically just a bunch of bytes. It's sort of segmented up into individual pages. Hey, that's why they call it page blob, I think.
How big are those pages?
I don't know.
512 maybe?
512? Sure. 512 bytes, it says it right here. I agree. And each one of those might have some data in it or it might not.
Right.
And the interesting thing about that is that you're charged based on the number of pages that actually have content in them. So the number of valid pages, we say, in the page blob.
So you could have 1 terabyte page blob and only have 1 megabyte or 100 kilobytes of actual content in there. You notice they did a mod too, that 512 thing?
Yeah, I did. That's power of two.
And you would only be charged for the amount that
just
you have
the
in there,
amount that you actually use.
which is fantastic.
Right, it's great. And it's really good for VHDs where we need to have a fixed size VHD, which means you've got to decide up front how big that sucker's going to be. And you may eventually need it to be 100 gigabytes or something, but right now you have barely anything in there.
Yep.
The nice thing about page blobs is as long as you save the page blob into blob storage correctly, you'll only have so many active pages, and that's all you'll be charged for. So that's where the trick comes in.
The keyword is correctly.
Correctly is the trick. And so this blog post is actually about how to make sure that when you upload a page blob, you are only uploading those non-zero bits, right?
Exactly.
And so the pages that are all zeros, you don't upload. You just clear them out. They count as nothing really,
right.
In terms of what you're billed for. Also in terms of what you have to transfer. Instead of transferring up 100 gigabytes of zeros, you get to just say, oh, all the rest is actually just empty pages. So there's some code on here actually, and this shows you just how can you efficiently upload and download the page blobs such that you only do the pages that actually have content.
Right.
I ignored this blog post entirely when I was doing my VHD stuff because I had Cloud Explorer, and Cloud Explorer has actually implemented this. So when you click this button and say upload page blob, it actually does the smart thing and it only uploads the pages that really matter. So if you're using this tool, and I'm not sure if any other tools do it this way yet.
Not that I'm aware of, but
that doesn't mean that they don't. But
but
for those of you who own these tools, this is a good idea. Please do this. That way people can actually upload these huge VHDs without worrying about it taking forever and costing a lot of money and all those things. So if you want to learn how to do it yourself, there is a whole bunch of code in here that really talks about how this works, why it works, everything you need really. If you go take all this code, you've actually got some tools that will do this for you.
Exactly.
So you can just do this from the command line, which as we know is my preferred way to do things.
Or just use the Clumsy Leaf.
Or just use Clumsy Leaf.
Yeah.
It's sort of strange that I didn't want to right-click to create the VHD, but I want to drag-drop in Cloud Explorer to upload it.
I was going to give you a little bit of grief about this not being a command line tool.
Yeah.
What was the word? Wuss?
Yeah.
I believe?
All right.
Well, there you have it, folks. We've ended the show on wuss.
It's a good way to end it.
So you can always get in touch with us through our Cloud Cover Show Twitter account.
And it works because this show was inspired by someone on Twitter asking for this very thing.
Yeah.
Not quite this very thing, but almost this thing.
We wedged it in.
We embellished.
Yeah. So
All right.
until next time, thanks.
Bye.